Right, today's lesson, we're going to be looking at condensation polymers. Just a quick review. The previous lesson was addition polymers, which was when many monomers of the same type essentially join together to form a long chain molecule called a polymer. So monomers make a polymer. We use alkenes with double bonds to form the polymer, and there was no other products on the side. That's why it was called addition. In condensation polymerization, a small molecule is going to come off, namely mainly water at GCSE. So condensation polymers are when two monomers with different functional groups join together and a small molecule is produced. So once again, two different monomers are linked together. So by different, they have to have different functional groups. Okay, and for the purpose of your syllabus, okay, at Excel people and the AQA people, it will be a dicarboxylic acid and a diol, which means a double carboxylic acid and a double alcohol combined together. Now, if you're AQA, there'll be a further lesson doing the other way you can form condensation polymers. So tune in for that. Before at Excel and AQA, you both need to know this basic one. So a dicarboxylic acid looks like so. Now, don't be panicked by the box. The box simply represents any carbon chain. It can be 1 carbon, 2 carbons, 3 carbons. It can be anything. The key part is if you look on the left and the right, you will see a COOH, carboxylic acid. If you look at the other molecule, diol stands for double alcohol. Remember, alcohols have an OH. So the green circle, remember, means just carbons. The important thing is got two OHs on either end. So these are double carboxylic acid, dicarboxylic acid, and double alcohol, diol. Now, when you bond them together, this is the essential rule. The OH is lost from the carboxylic acid, and just the H is lost from the alcohol. That's crucial. That will then release water, and the carbon with the double bond O on the left will bond with the oxygen on the right with a single bond. So this was what will form. This was actually the foundation of esters. Now, when you make polyesters, poly means many esters, look at the difference. Okay, so you've got many of these units joined together. And so what essentially happens that's different, let me just annotate, is here and here, you've left it open-ended. So this is actually what the polymer looks like. Now I'm going to draw this out and show you how it works as well, to make sure you understand. So I'm going to go through it now, just a little bit slower for you. So if we move that and put this on, remember these notes will be attached. And we just expand this middle one because we're doing EdXL and AQA. What happens, watch carefully, you always circle the H from both sides of the alcohol because the alcohol loses the H. The carboxylic acid loses the OH on both sides. Now, this oxygen is essentially going to go and bond to this carbon. And that's the bond that you see here. So you copy this as it is, but the H is gone. So you have to have an open bond through the bracket. Then you have your CCO. Then this O joins to this C double bond O. That's what you see here. This is the ester linkage, remember, COC. You copy this, and then remove the OH, line through the bracket. As a result, water comes off. Now, if we want to have N of this and N of this, then we have to put little n here, and we have to put 2n minus 1 H2O. You might see it written incorrectly in the syllabus. You might see it written incorrectly in old editions of textbooks. It is 2n minus 1 H2O. However, for the GCSE purpose, they're not going to mark you on that. They'll just focus on the fact that you've made water. Now, why is it 2n minus 1? Well, if you picture another diol here with an OH, and you picture another dicarboxylic acid here. Then what you got to picture for yourself is that this will form water here, this part, and this part here with the H will form water. So when N is equal to 2, because there's 2 of each, notice that you get 1, 2, 3 waters out. And if you plug 2 into here, 2 times 2 is 4, minus 1 is 3. So that's how it comes about. But again, you don't need to get bogged down on it. There's a lot of new information, but this is the part that will form the est. So all I can do is go over like another few examples, essentially, okay, from scratch. So if I just get my pen, I can draw you a few more just to make sure you're comfortable. It is the higher tier part of the course, the grade 9, grade 8, 9 stuff. So let's take, for example, let's take a different approach. Let's take this. That's our carboxylic acid. So I'm going to do 2 examples for you. And I'm going to combine it with a double alcohol, and I'm going to make the alcohol like this. So it really doesn't matter what's in the middle. That's why they used the circle and the square at the beginning. Now, look at the essential part. Take the OH off from both sides. I'll just put the N. Remove the OH from the carboxylic acid. Remove the H from both sides of the alcohol. And simply link your carbon to your oxygen, drawing everything else as it is. So because this is gone, we're going to start with a C double bond O with an extended line. We're going to copy the rest of the structure in. Then this C will bond to this O. Then we copy the rest. You don't need to know how to name these, by the way, even at A level. Then you put O. H is gone. Extend your line. Whack on your brackets and put your N. Plus 2N minus 1 H2O. That is how you do it. So just stick to the basics. The OH comes off of the carboxylic acid and the H comes off of the alcohol. Now you can also be asked to work backwards. So you should be able to work forwards and backwards. So if I drew out a polymer, you should be able to go backwards. So if I drew this, whoops, that's not an ester. This is just abbreviated CH2, CH2 instead of drawing it. If someone gave you this and they say, what 2 monomers were used to form this? Then what you do is you break it here and you add back the groups that were lost to make the water. So the one with the double bond O was a carboxylic acid, so you must add an OH on both of them. So that will be the first monomer by adding an OH on both sides. Then this will be part of the alcohol, so you add an H on each of these oxygens. And voila, that's your answer. These are the 2 monomers used to form the polymer. Okay. Now, again, to emphasize, when we put the brackets, we have the polymer structure. If we want to draw repeat units, then I would avoid drawing the brackets. So I would just, wait, let me save this. If I'm drawing just repeat units, I would simply do this. So if I'm doing 1 repeat unit of this polymer, it looks like this. If I want 2 repeat units, I must repeat the whole thing again. Annoying if they ask you to do this, but they can ask you. So just like the addition polymers, make sure each end is open-ended. Okay, this will be 2 repeat units. Whatever you do, do not put a bracket like here and here, because then that's wrong. If you're obsessed with brackets, they would go here and here, and that'll be one repeat unit. Okay, but don't put brackets on repeat units. Brackets only go onto the polymers. Right, that completes the condensation polymer part. If we just double check that we've covered everything we need to cover. The only thing that you should also be aware of is that condensation polymers are biodegradable, which means they can be broken down with water. So next lesson, I mean, this is actually the last lesson for the EdXL people. That actually will complete your organic course. So just remember, when you dispose of them, they can be biodegradable, which means that water can be used to break this down, because this bond is actually weak and this carbon can like attract molecules. You'll learn more about that in A level, but for now, just learn it's biodegradable, which means bacteria can break it down. And that's why the condensation polymers are better for the environment from that sense. Because remember, addition polymers have the strong CC bonds, which don't break, and they're non-biodegradable. So they take up the landfill. Okay, so congratulations, EdXL people. You've now finished your organic course. AQA people, you have to tune in for the other lesson on polyamides and on natural polymers. So good luck and see you then if you're AQA.